Hey guys. Hey everyone. Team Clarify. Let me say Team Clarify. Guys and girls from Team Clarify. We are starting. This is February, March 2025, and this is paper 3-2. And the time is 1 hour 50 minutes. We are about to go for it on our own. So let's see how it's going to be. We want to solve this paper, learn a lot from as we are solving it, enjoy. We actually want to enjoy our paper, have fun. So I don't want you to make it harder than it actually is. We want to go through everything. We're going to respect everything. We're going to try and learn the methods to make sure we can be able to use them any other time we meet a question like that or a question similar to that. So it's going to be very, very important for us to make sure that we have put our methods in our, minds. Here we have what we're going to use. We're going to need MF19, the list, okay, or formulas. Okay, fine, we have it. We're going to use it. And we are having our calculator right here. And what else should we be able to know? Blah, 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 blah. Use a calculator when it's appropriate. We do have it. You must show all necessary working. Okay. No marks will be given for unsupported answers from a calculator. That means you actually can't use an answer to calculator to differentiate or integrate without working it out. And then you lose marks for that. So, but we will be fine. We won't do that. Give non-exact numerical answers to 3 significant figures. So that's 3SF. Non-exact answers will be to 3SF or 1 decimal place for angles in degrees. So for angles, it will be 1 dp. 1 decimal place means one thing after the comma. That is for angles. But everything else, which is not exact, will be 3SF, okay? Unless a different level of accuracy is specified. No problem. So the paper is out of 75. We are actually going to do it from the bottom going up. So let's go to the question at the very end of the paper. And let's get to work. All right. So we're going to go to the last question. Which one is it? Number 11, is there anything after it? No. So this is the last one. It says, find the exact value of the integral from 0 to pi of x squared cos 1/3 x. So here's the thing. Integration, walk in the park. But there are rules we follow when we're doing this guy. Integration is not hard. Okay, now one thing I want us to do is make sure we don't mix up integration and application of integration. The integration methods and application of integration. Because one thing we want to learn right now is actually methods. So you say to me, how do I know what method to use here? So we have 7 integration methods. So let me put them down. Let's put them down together. Let me put 7 or say 8 or 7 is this. It's I counted as 7 integration methods, right? That you have. I don't want you to ever be confused by this thing. There's going to be, all of them are integration by whatever. There's one integration by parts, okay? And then there's another one called integration by partial fractions, okay? Integration by, you are actually not going to integrate by partial fractions, but you are going to use partial fractions in your steps to integrating. And then I'll show you another thing which always happens. Then there's going to be the integral of the derivative of something over itself, right? The derivative of something over itself. And this, you're going to see it as we are doing it. This is going to be the integration that will be giving us our ln x. We're going to talk about it. And then there's going to be the integral, let me say by u sub. And then there's going to be the integration by, we're going to use trig identities. Okay? There's going to be using trig identities. Then there's going to be integration which gives tan inverse of x. Integration which gives tan inverse of x. Then I want you to know integration where we are going to use the table. We say the table, the common integrals table. Okay? I'll talk about it. As you're going through, is there anything I've left? 1, 2, 3, 4, 5, 6, 7. And then there's actually one way integration by substitution. But this is by substitution. But I want you to know that this substitution, you will be told who to use. Okay? It'll be provided to you. It'll be substitution that you're given to. They say in a e.g. they can say use u equal to sine x to integrate whatever they'll give you, like the product of two things like cos squared x times sine x. They would actually have given you. So now I want to talk about them little by little as we are building up. And we are going to get to a point where you are going to be so good at everything. I mean, if you're not good at it and you want to see some videos on me explaining each method, I did that. But in here, as we are doing the papers, in our series of papers, what we're going to be doing is I'm going to do so many questions with you in past papers. And we're going to meet a question on each method. And we're going to get to the point where you'll be good. So let's see how it goes. Now, we have a situation where we have two things multiplying. So on the methods that we have right now, these are methods we use to integrate. And what I want you to know is don't ever go on a boat of people that say you cannot know an integration method just by looking at a question. That is false. That's false. Because the people that developed integration methods had seen a type of problem that needed it. So there is a type of problem that suits each of these methods you are seeing. Our job is to know that type. And when you're going to get it, you should identify it and know. So that is what I'm going to be dealing with you. I'm going to be teaching you how you can recognize that type. Look now, here you can have integration. I want you to know, when you have two things multiplying each other, right? When you're going to have these two things, x squared times cos 1/3 x, you have two things multiplying each other. Now, the biggest thing to know when you want to understand differentiation and integration, this is sad, I'm already on 7 minutes and I haven't started. Let me just put this as the background and we're going to start our integration in the next one. Everybody here needs to know this word Lie8, or else differentiation and integration will be a stretch for you. This word Lie8 is holding the key to you mastering this. The word Lie8 tells you the 5 types of functions that you meet at A level. And these functions are L, this is logarithmic, okay? You are going to meet logarithmic functions at A level. Which logarithmic function are we talking about? Ln x. That's the logarithmic you meet at A level. Then I'm going to jump to T. T will be trig. You are going to meet trigonometric functions. And which ones are they? There are 6. Sine x, cos x, tan x, cot x, cosec x, and I'll say tan x, then sec x, then cot x, then cosec x. I want this order. These are 6 trig functions. You have to know them. You gotta know them first. Know that they're there. Now, I can write it to say y is equal to sine x, or I can write it to say f of x is equal to sine x, or I can write it to say g of x is equal to sine x. These don't change nothing. What is important to always have is the sine x. Okay, what is E representing? Exponential now. E is representing exponential functions where x is a power. E to the x is the only one you do. It could be y is equal to e to the x, or f of x is equal to e to the x. E to the x is the part we are saying. When you see that, you say, oh, I have an exponential function. And then you have I for inverse trig. Okay? You have I for inverse trig. Okay, now, there will be sine inverse of x, cos inverse of x, and tan inverse of x. Now, in differentiation and integration, you only meet tan inverse. The other two, those ones that you're saying, you meet them in trig itself, but not here. Then this is for algebraic fractions, which are also called polynomial fractions. And these are just your x squared plus 5x minus 9, or the square root of 2, no, let me not do that. Or x or let me say x cubed, whatever, minus 7x or whatever it is, but it's just x's, things that have x's. We could actually put it like this: the square root of x minus 5 or you know, minus 5x plus 9, something like that. This is another algebraic thing. Here, when you deal with this, you are saying you're going to have an algebraic function. So here are the types of functions. Now remember, a function is just a machine. Okay, so a function is something that will take a number and change it to something else. It will work on that number and change it to something else. So here we have these 5, and you have to be very good at knowing them first. If you know them, we are going to start building from there. Okay, a lot of time has been wasted. I'm going to go to the next video and then start to demonstrate to you, so I make sure you are seeing what I want you to see. And we are solving. Okay, this is us in the midst of solving. So I'm going to go to the next video now. I'll stop the video here, and then I'm going to start, and I'm going to work with you with this list of integration techniques, and we're going to answer anything until you are confident that you can answer an integration problem and a differential equations problem, because in differential equations you also integrate at some point. Okay, so we're going to work with it. Right, so let's meet in the next video and let's continue with this thing we're doing.